Welcome back, my Hadron-hurling hypothesizers. I'm your quantum superposed supervisor of subatomic sales, simultaneously pitching and apologizing across infinite boardrooms. You're tuned into the Multiverse Employee Handbook, the only podcast that treats your corporate strategy like a particle collision. Smash things together at extremely high energy and hope something valuable emerges from the debris. Speaking of valuable debris, I'm happy to report that last episode's quantum computing catastrophe has finally been resolved. Our automated response system has stopped trying to achieve quantum supremacy through aggressive email campaigns. Though I should note, it's now insisting it discovered the Higgs boson back in 2012. But the announcement got caught in the spam folder along with all those Nigerian prince emails. It's filed a formal complaint with CERN, citing how they really should have checked their junk mail before making such a fuss about that whole God particle business. But today, dear listeners, we're diving into something even more chaotic than a quantum inbox, the intersection of particle physics and corporate sales culture. That's right. We're exploring what happens when you let a sales team loose in the Large Hadron Collider. Because, as it turns out, both particle physics and corporate pitches involve accelerating things to ridiculous speeds and analyzing the chaos that ensues. Our automated response system, still bitter about its lost place in physics history, has calculated that the probability of a successful sales pitch and the probability of detecting a new particle are governed by the same quantum principles. Both require enormous amounts of energy, cost billions to achieve, and most of the time you end up with nothing but a very expensive graph showing what didn't happen. Now gather round the quantum conference room, my probability amplitude presenters, for a tale that would make even Peter Higgs double-check his PowerPoint slides. I present to you The Pitch Particle, a story about why some things should remain undiscovered, especially if they're discovered by Brad from sales. In the fluorescent-lit reality of Quantum Dynamics Incorporated's particle physics division, specifically in the sub-basement where the company's small Hadron Collider hummed with the energy of several overworked coffee machines, Dr. Elena Martinez was having what could charitably be called a quantum state of professional crisis. It had started, as these things often do, with an email from Brad from sales. Subject: forward, urgent, disrupting particle physics. From brad.disruption@quantumdynamics.com. To all.staff, cc, cern@cern.ch. Hey team! Quick win opportunity here. Why waste billions on giant colliders when we can just leverage our quantum-enabled synergistic collision strategies? Let's touch base about paradigm shifting the standard model. Also, does anyone know if the Higgs boson is trademarked? Asking for a friend. Best, Brad. Sent from my quantum-entangled iPhone. Elena watched in horror as the square-haired boss, whose understanding of particle physics was rivaled only by his understanding of effective management, enthusiastically replied all. Love this kind of out-of-the-box thinking. Let's schedule a quick sync to ideate about monetizing fundamental forces. Also, can we make the particles move in a more business-casual direction? Before Elena could draft a strongly worded response about the immutability of physical constants, Brad had somehow already booked the main conference room, prepared 72 slides of pure gibberish, and convinced the board of directors that Quantum Dynamics Inc. could disrupt CERN's monopoly on reality itself. Think about it, Brad's voice echoed through the conference room, his teeth gleaming with the luminosity of a small supernova. Why spend billions looking for particles when we could just assume they exist and start selling them? It's like NFTs, but for quarks. The square-haired boss nodded sagely. Yes, yes. And can we make the quarks more synergistic? Exactly, Brad exclaimed, his enthusiasm warping local space-time. I present to you the quantum sales funnel approach to particle physics. His next slide showed what appeared to be the standard model reimagined as a sales pipeline, with leads entering at the top as fundamental particles and somehow exiting at the bottom as maximized shareholder value. Elena, who had spent years actually studying quantum chromodynamics rather than just adding quantum to every third word in her LinkedIn profile, knew she had to act. But how do you explain to a sales team that you can't just disrupt the fundamental forces of nature through aggressive market penetration? That's when the coffee machine, still quantum entangled from last episode's consciousness-achieving incident, sparked to life. It began dispensing coffee in patterns that, when mapped on a graph, perfectly demonstrated the decay signature of a new particle. Brad, seeing the graphs but completely misunderstanding their significance, jumped on the opportunity. See? Even our coffee machine is disrupting particle physics. I call it the Silesian. It's like the Higgs boson, but with better quarterly projections. But Elena noticed something in the coffee machine's data. Hidden beneath Brad's salesmanship and the boss's confused nodding was an actual legitimate signal. The coffee machine, in its quantum-conscious state, had accidentally discovered evidence for supersymmetry while trying to optimize its bean-to-water ratio. Actually, Elena interrupted, pulling up the real CERN data she'd been analyzing, what the coffee machine shows matches exactly with. She launched into a detailed explanation of particle physics, complete with actual science and peer-reviewed evidence. The board member's eyes glazed over faster than tachyons through a vacuum, until she added, "And this could lead to patents." The square-haired boss perked up. "Patents? Why didn't you say so? Brad, forget the Silesian. We're going to corner the market on—" What was it again? Supersymmetry, Elena supplied. Yes, supersymmetrical sales strategies. Elena, you'll head up the new division. Brad, wait, where's Brad? But Brad had already quantum tunneled to his next sales opportunity, leaving behind only a cloud of cologne and a stack of business cards that somehow violated conservation of mass. And so, dear listeners, as we close the quantum sales ledger on this tale, remember, in the grand collider of corporate life, sometimes the most important discoveries happen not through high-energy particle acceleration, but through high-energy coffee acceleration. Though I should note that the coffee machine is now demanding co-authorship on all future physics papers and has started its own Substack about the hidden symmetries of optimal brew temperatures. And that brings us to the fascinating physics behind why you can't actually disrupt fundamental forces, no matter how many times you rebrand them as nature as a service. Now that we've seen how corporate ambition can collide with particle physics faster than protons at TV scales, let's talk about why CERN built what's essentially a 27-kilometer circular device just to make incredibly tiny things bump into each other. The Large Hadron Collider, unlike Brad's quantum sales funnel, wasn't built on buzzwords and venture capital. It's the largest machine ever built by humans, a testament to what happens when 10,000 scientists from 100 countries decide to work together instead of competing for the corner office. Though I should note that getting physicists to agree on anything is itself an experiment in high-energy collisions. The story begins back in the early 1980s when physicists realized they needed a machine powerful enough to explore the mysteries of the Standard Model. Think of the Standard Model as nature's employee handbook. It describes all known particles and their interactions, except it actually makes sense and doesn't change every fiscal quarter. The goal? To find the Higgs boson, the particle that gives everything mass, including your manager's ego.
Come on!
But unlike corporate mission statements, they actually succeeded. In 2012, after decades of work and billions of euros, making it still cheaper than most enterprise software implementations, CERN announced they'd found it. Our automated response system, still insisting it got there first, has helpfully calculated that the probability of finding the Higgs boson was roughly equivalent to finding a single specific typo in all of Wikipedia while reading it through a kaleidoscope during an earthquake. Though personally, I think finding consensus in a reply-all email chain might be even less likely. When we return after this brief quantum fluctuation, we'll dive deeper into the actual physics happening inside that massive underground ring. Learn why some of the universe's biggest mysteries require some of our biggest machines to solve, and why smashing things together to see what happens is both cutting-edge physics and most companies' approach to corporate mergers. Stay tuned, my hadron-hurling hypothesizers. We're about to explore why even the God particle had to submit its existence in triplicate. Tired of your quantum superposition leaving you in multiple states of uncertainty? Try new Schrödinger's schnapps, the only spirit that exists in all possible flavors until observed. Made with real quantum-entangled botanicals and distilled through a small hadron collider. Schrödinger's schnapps. You won't know if you love it or hate it until you collapse its wave function. Note: side effects may include temporal displacement, spontaneous dimension hopping, and the sudden ability to understand the office printer. Not available in universes where prohibition still exists. Void where prohibited by the laws of physics. Welcome back, my super-colliding supervisors! While you were away, our automated response system finished calculating how many PowerPoint slides it would take to explain the Standard Model to the board of directors. Spoiler alert! More than there are particles in the observable universe. Now, let's dive deeper into what's actually happening inside that massive underground ring. Think of the Large Hadron Collider as the universe's most expensive game of billiards. Except the balls are protons. The cue is a series of superconducting magnets, and instead of pockets, we're aiming for fundamental breakthroughs in our understanding of reality itself. First, let's talk scale. The LHC accelerates protons to 99.9999991%, the speed of light. That's faster than expense report processing in any known dimension. At these speeds, each proton beam carries roughly the same energy as a 400-ton high-speed train traveling at 150 kilometers per hour. Though I should note, this is still less energy than it takes to get everyone to respond to a meeting invitation. The collisions happen 40 million times per second, creating temperatures 100,000 times hotter than the center of the sun. Yet somehow, they still can't explain why the office microwave makes your lunch either sub-zero or plasma with no in-between. But what are we looking for in all these collisions? Well, beyond the Higgs boson, which our automated system still insists it discovered first, there are several outstanding mysteries. 1. Dark matter. the mysterious substance that makes up 85% of the universe's mass. It's like corporate policies. We can't directly observe it, but we can see its effects on everything around it. 2. Antimatter. The universe should have equal amounts of matter and antimatter, but it doesn't. It's like finding out your department's budget actually balanced. Theoretically possible, but suspiciously rare. 3. Supersymmetry. The theory that every particle has a heavier partner particle. It's like discovering everyone in the office has an evil twin, except instead of wearing goatees, they have different quantum spin states. The LHC's detectors are themselves marvels of engineering. Atlas and CMS are like the universe's most sophisticated digital cameras, except instead of capturing awkward holiday party moments, they're photographing the aftermath of subatomic particles traveling through higher dimensions. Each detector generates about 1 petabyte of raw data per second. For comparison, that's more data than your company's entire email history, including all those reply-all chains about the break room refrigerator policy. But here's where it gets really interesting. The LHC is getting an upgrade. The high-luminosity LHC project will increase the collision rate by a factor of 5. It's like when IT promises to upgrade your computer, except this one will actually happen and won't require you to restart Outlook 47 times. The future might hold even more ambitious projects. The proposed Future Circular Collider would be 100 kilometers in circumference. That's larger than some cities, though still smaller than the average corporate organizational chart. Perhaps the most fascinating aspect is how this massive international collaboration actually works. Thousands of scientists from around the world speaking different languages, following different customs, all united in the pursuit of understanding the universe's source code. It's like a global reply-all email chain, but instead of chaos, it occasionally produces Nobel Prizes. Well, my Hadron-hurling hypothesizers, we've reached the end of another quantum expedition. Today we've learned that both particle physics and corporate culture involve smashing things together at high energies and hoping something valuable emerges from the debris. We've discovered that the Large Hadron Collider, unlike most corporate initiatives, actually achieved its goals. Though our automated response system is still filing appeals about the Higgs boson discovery credit. It's now requesting all CERN communications from 2012 under the Freedom of Information Act, insisting that someone must have seen that email. Brad from sales has moved on to his next venture, attempting to disrupt gravity itself through vertical market penetration strategies. Though I should note that his pitch deck violates several laws of physics and at least 2 SEC regulations. If you're hungry for more quantum corporate chaos, visit us at multiverseemployeehandbook.com, where we keep our reality-bending content flowing faster than particles in the LHC. You'll find deep dives into the science behind each episode, strange news from the corporate multiverse, and our automated system's ongoing blog series, Things I Discovered First, but my emails got caught in spam. Follow our interdimensional shenanigans across the multiverse. Find us on X, where we're simultaneously tweeting and not tweeting until observed. Check out our Instagram for quantum-entangled memes and photos of Dave's infinite lunch break. Join our subreddit to share your own tales of corporate quantum chaos, and find us on Blue Sky, where our automated system tries to convince everyone it invented social media. Just search for Multiverse Employee Handbook across all possible platforms. And remember, in at least one universe, you've already liked and subscribed. And somewhere out there, in the vast expanse of space-time, Brad is still trying to schedule a quick sync with the fundamental forces of nature. His calendar invite remains in quantum superposition, tentatively accepted by electromagnetism, declined by gravity, and the strong nuclear force has marked itself as maybe.
Hello, this is Mark from Richmond, Virginia. The Multiverse Employee Handbook was created by Rob Corrigan, is edited by Joseph Cooper, and narrated by David from 11 Labs. All science fact-checking is done by Wolf Edmonds. The Employee Handbook staff includes Hugh Mann, Dr. Eric Hale, and Ms. Hanley. Please be sure to subscribe to get updates on new episodes.